Good morning friends. In this lecture I am going to solve problem on one-dimensional heat flow equation. Or students, one-dimensional heat flow equation. Let us see the problem, students. The temperatures at one end of a bar OA of 50 centimeters length with insulated, okay students, it is insulated sides, are kept at 0 degree centigrade and 100 degree centigrade. Okay students, there is a bar. What is say students? OA. So one end is A, O, another end is A. What is length, students? Length is 50 centimeters. 50 centimeters. It is insulated and sides are kept at 0 degree centigrade and 100 degree centigrade. 100 degree centigrade. One end is 0 degree centigrade and another end is 100 degree centigrade. Until steady state conditions prevailed. What students? Steady state condition prevails. Okay, throughout the bar, steady state conditions prevail, students. Steady state. Find the steady state temperature. What is say, students? Find the steady state temperature. Okay, so this problem is a one-dimensional heat flow equation, students. So one-dimensional heat flow equation. What is the equation, students? Dou u by dou t, that is equal to c square into dou square u by dou x square. Say this is 1, students. This is 1. Okay, what is state, students, here? Steady state. So steady state, when it is steady state, time is independent, students. Time is independent. So we get here dou square u by dou x square, that is equal to 0. If I solve and substitute the conditions, then we get initial temperature, students. We get initial temperature. See, so dou square u by dou x square, that is equal to 0. So symbolic form. What is symbolic form, students? D square u, that is equal to 0. That implies auxiliary equation, students. Auxiliary equation. D square is equal to 0. That implies D is equal to 0 comma 0. So what is complete solution, students? U is equal to 0 comma 0, students. So C1x plus C2 into e power 0x. E power 0 means value is 1, students. Value is 1. Okay. Now see, students, U is function of x. U is function of x. Now at the O, that means what is length, students, here? U of 0. At O, x value 0, students. So u of 0, what is value, students? 0. And u of, what is length, students? What is length? 50. So another end A is 50, students. So u of 50, that is equal to 100 degree, students. 100 degree centigrade. Now I want to substitute this condition, students, here. So u of 0, that is equal to u of 0, that is equal to, see, students, x value 0. So this value is 0 into C2. So this value is equal to 0. That means C2 value 0, students. C2 value 0. So this equation becomes here. This equation becomes here. U is equal to C1x. U is equal to C1x. Now I am using this condition, students. So u of 50, that is equal to C1 50. That is equal, this value is equal to 100, students. That implies C1 is equal to 100 by 50, that is equal to 2, students. C1 value is 2. So this equation becomes here U is equal to C1 value is 2, so 2x. That implies U is equal to x means here, students, it is initial temperature. What, students? It is a initial temperature. Actually U is function of x. See here, U is function of x, students. So initial temperature. So U of x comma, what is t value, students? 0. That is equal to 2x. That is equal to 2x, students. Say this is 2. This is 2. Now what he says, students? Insulated. Okay, students, insulated insulated both ends O and A. Okay students, it is insulated. When it is insulated, there is no change students in the temperature. So dou U by dou X at X is equal to 0. So the value is students 0. And dou U by dou X at X is equal to 50. The value also 0 students. So this is 2 and 3 students. Sorry, 3 and 4 students. 3 and 4. I want to write here students. I want to write here. So what is 2 U of x comma 0, that is equal to 2x. This is 2. And dou U by dou X at X is equal to 0 is equal to 0. It is 3. Dou U by dou X at X is equal to 50 is also 0 students. Also 0. Let us see the transient state solutions. Let us continue students. By using these conditions, say 2, 3, 4, we can find the solution students. Let us see. Now, what is transient state solution students? Transient solution. What is transient solution students? U of x comma t, that is equal to C1 cos px plus C2 sin px into e power minus p square c square into t students. C square p square c square into t. So this is 5 students. This is 5. Now I want to use this third condition students. Third conditions. See here I have dou u by dou x. So you differentiate students. Dou u by dou x, that is equal to, common differentiate students, you get here C1 derivative of cos px students with respect to x. So minus sin px into p. So minus C1 p sin px plus here also students we get C2 p cos derivative of sin students, so cos px into, there is no x students, so e power minus p square c square t plus c square t. Now you substitute. Now dou u by dou x at x is equal to 0 students. Dou u by dou x at x is equal to 0. So x value is 0 students. So sin 0 0, c2 into p cos 0 value is 1 into e power minus p square c square t students. This value is equal to 0. This value is equal to 0. Clearly here c2 into p, that is equal to 0, since e power minus p square c square t is not equal to 0 because it is a solution students. It is a solution. This is general solution students. So here C2 may be 0 or p may be 0 students. So here C2 is equal to 0 or p is equal to 0. P is equal to 0. Both okay. If p is equal to 0, okay students, if p is equal to 0, see students here, if p is equal to 0, what we get here? What we get here? Come on, tell me. 5 becomes u of x comma t, that is equal to p value 0 students. So cos 0 1, so we get c1, sin 0 0, e power 0 value 1 students, e power 0 value 1. So whenever p is equal to 0, I get here u of x comma t, that is equal to c1 students. I want to write here a naught by 2 students, a naught by 2. Say this is 6 students, because I am applying the concept of half range series students or Fourier series concept. Fourier series concept. So if C2 is equal to 0, no, if C2 is equal to 0, now 5, C2 is equal to 0, 5 becomes u of x comma t, that is equal to ct value 0 students. We get a c1 cos px into e power minus p square c square into t. So this is 7 students. Therefore u of x comma t that is equal to, what is complete solution students? a0 by 2 plus c1 cos px into e power minus p square c square t. Say this is 8 students. This is 8. Now I want to substitute the second condition, dou u by dou x at x is equal to 50. Find dou u by dou x here students. Dou u by dou x that is equal to a0 by 2 is constant student, so the value is 0. Okay, value is 0. C1 derivative of cos px students minus sin px, so minus sin px into p, that means you can write here c1 into p e power minus p square c square into t. So from condition 4 students, from 4 dou u by dou x at x is equal to 50, that is equal to, so minus c1p sin 50p e power minus p square c square into t, that is equal to 0 students. This value is equal to 0. Value is equal to 0. So clearly here sin 50p that is equal to 0 students, since e power minus p square c square t value is not equal to 0 because it is solution. c1 and p is not equal to 0 students. c1 comma p is not equal to 0 because c1 equal to 0 means we get okay students, we get general solution becomes 0 students. P value not equal to 0 students. So sin theta is equal to 0 means theta is equal to n pi, where n is equal to 1, 2, 3 and so on. 1, 2, 3 and so on. Okay students, here I have 50p students in place of theta, so 50p that is equal to n pi, where n is equal to 1, 2, 3 and so on. So p is equal to n pi by 50 students. So here students, p is equal to n pi by 50. So 8 becomes students, 8 becomes, come on tell me students, u of x comma t that is equal to, I want to write directly students, a0 by 2 plus I want to write directly summation students, summation sigma n is equal to 1 to infinity, because n value 1, 2, 3, 4 and so on students. In place of c1 I want to write an students, n, I want to substitute n is equal to 1, 2, 3 and so on infinity, so for our convenience, into cos px, cos p value students n pi by 50, so n pi x by 50, into e power minus p square students. So we get here n square pi square pi square c square t by 50 square students, so 2500. Say this is 9 students, this is 9. So I need here this equation students, so I want to write here students. So u of x comma t that is equal to a0 by 2 plus sigma n is equal to 1 to infinity an cos n pi x by 50 e power minus n square pi square c square t by 2500. This equation number is 9 students. Now I want to find a0 by 2 value and an value students. Let us continue students. Now I want to apply 2 students. 2. What is 2? U of x comma 0 that is equal to, so t value 0 students here. I want to substitute t is equal to 0. Here I have t is equal to 0 students. E power 0 value is 1. So finally I get here a0 by 2 plus sigma n is equal to 1 to infinity an cos n pi x by 50. So u of x comma 0 value students 2x. Now say students, it's like a half range cosine series. What students? Half range cosine series. Half range cosine series. What is formula, students? F of x that is equal to a naught by 2 plus sigma a n cos n pi x by c, students. N pi x by c, because say here interval is 0 less than x less than c. So what is a naught value here, students? 2 by c integral 0 to c f of x dx. And a n value, students, 2 by c integral 0 to c f of x cos n pi x by c into dx, students, into dx. So here first I want to find a naught value, students. A naught value. So a naught that is equal to 2 by c, students. So 2 by, what is c, students, here? 0 less than x less than, here 0 less than x less than 50, students, 50. So 2 by 50 integral 0 to 50. What is f of x, students? F of x is 2x into dx, that is equal to, you get to 1 by 25, that means 2 by 25, no, 1 by 25, students, because x integral of 2x is x square by 2, 2 cancel, students, we get here x square 0 to 50, so that is equal to 50 square, students, so 2500 by 25, so we get here 100, students, we get 100. This is a naught value, students. A naught value, we need here a naught by 2, students, so a naught by 2, so a naught by 2 value is 100 by 2, that is equal to 50, students. Now we find a n value, students. A n, that is equal to again 2 by 50 integral 0 to 50 f of x is 2x, and here we have cos n pi x by 50, students, cos n pi x by 50 into dx. Say apply uv rule, students. Say this is u and this is v, students, this is v. So what is uv rule, students? Integral of uv that is equal to u v1 minus u dash v2 plus and so on and so on. We can take also 2 outside, students, so that is equal to 4 by 50 bracket x into integral of cos n pi x by 50, students, so sin n pi x by 50 divided by n pi by 50, students, n pi by 50 minus derivative of x is 1, again integration of sin n pi x by 50 by n pi by 50, students, we get here minus cos n pi x by 50 divided by n pi by 50. Already I have n pi by 50, students, so we get here n pi by 50 whole square, bracket close, between the limits 0 to 50, so that is equal to 4 by 50 bracket. See, students, here if I substitute upper limit here 50 cancel, students, sin n pi value 0, students, minus and minus plus, again I substitute 50 cancel, cos n pi value minus 1 whole power n, students, so 2500 by 50 square, students, 2500 by n pi whole square. Now substitute lower limit, students, sin 0 value 0, I am substituting lower limit, students, so minus, already minus and minus plus, lower limit is minus, okay, finally I got minus here. Cos 0 value is 1, so 50 square, and that means 2500 by n pi whole square, Now taking count 2500 by n pi whole square, students, we get here 4 by 50 into 2500 by n pi whole square into minus 1 whole power n minus 1, so that is equal to, this is here 50 times 200 by n pi whole square. See, students, here n is even student, n is odd, students, odd means we get 1 minus 2, so we get here minus 2, students. N is even, the value is 0 students, n is even, the value is 0. Therefore 9 becomes u of x comma t, that is equal to a naught by 2 values 50 students, plus sigma n is equal to, here it defined from odd values, so 1, 3, 5 and so on to infinity, minus 2 into 200 students, we get here minus 400 by n pi whole square into cos n pi x by 50 into e power minus n square pi square c square t by 2500, which is the required solution of a given problem, students. Given problem. See students, initially he given the maintain at 0 degree centigrade, 100 degree centigrade students. Steady state reach students. Okay, steady state reach means we get here the initial temperature u of x comma 0 is equal to x. Okay, and then the at O and A are insulated students to prevent the loss of heat. So there is no rate of change, students. So dou E by dou x and dou E by dou x at 50 values are 0. Now I am substituting these conditions, we get C1 C2 value, students, and finally we get like this, students. Okay students, please subscribe my channel, students, like this video and share it, students. Hope you understand. Thank you for watching this video. Jai Hind.